In section 10, we're going to begin an introduction to matrices, and we're going to start with the matrix structure. But ultimately, the purpose of getting this introduction to matrices is so that way in section 11, we can look at the fourth method for solving a linear system called Cramer's rule. And we're going to start with the definition 10.1. It says an array of numbers arranged in rows and in columns and then placed in brackets. So the brackets that we're referring to here are going to be the square brackets, which are similar to the ones that we would use in interval notation, but this is not going to be interval notation. This is going to be another use of the square bracket. This is what we call a matrix. For those that have had any programming background or maybe a computer science major, you're probably familiar with the word array, which is going to be a string of numbers or a string of values all listed out. And what we're going to have here with matrices are known as multi-dimensional arrays. So we don't just have to have one row, but we can have multiple rows as well as multiple columns. So example 10.1, we're going to go right into that. It's going to show you some examples of what these matrices could look like. So let me show you an example here. Open up my square brackets, and inside I'm going to put 4 entries, 2, 3, 4, and 7. So we are to view this as 4 separate entries where there is a first row, a second row, a first column, and a second column, making 2 an entry, 3 an entry, 4 an entry, and 7 also an entry. So we're not to think of this as 23 or 47, and nor do we have to have commas in between to be able to separate out the various elements. All we have to do is put space in between them, and it looks like I've erased part of this bottom left entry. It should be 4. And when we name a matrix, conventionally we use capital letters, so we'll call this matrix A. Another example of this, I'm going to call this next one matrix B. Now with matrix B, I'm going to introduce a naming convention for the individual elements. So we're going to be using a subscript notation with indices. So there are 2 different index values that we're going to have. One of them is called I, one of them is called J, and I'll write that word down. These are called the index, or the indices for plural. And it's really useful to have this style of notation, especially when you start getting larger matrices that you work with. So for example, I'm going to create a matrix, and I'm going to say that the top right entry, or excuse me, the top left entry is the 1, 1 entry. It's tempting to look at that as the 11 entry, B11, but it's supposed to be thought of as B11. The first one represents the row that you're in, which is the I index, and then the J portion of the index is supposed to represent the column. So this entry, B11, is the first row, first column. Then if I go to the right, put a little space, I can put another entry, and this is still in the first row, but now I'm in the second column, which is why it's the 1, 2 entry. And I'll do one more column in this first row, and it'll be the B13 entry. Now I'll switch to the second row, first column. That's entry 2, 1. Next to that will be entry 2, 2. And then next to that will be the second row, third column, and that will be subscript there 2, 3 with our indices. So that's a nice little convention that we have for working with larger matrices. Don't necessarily need that with small ones, but with large ones it's really helpful. And then let me give you one more final example. C is going to be, use capital C, and this matrix is perhaps the most boring of all the matrices. It only has 1 entry, which means it only has 1 column and 1 row. That's it. The last part that we're going to look at here is definition 10.2. And definition 10.2 is going to describe something called order. It says the number of rows and columns that a matrix has is called its order. Now I want you to think of order as basically the size of the matrix. It's effectively what it is. It's just the size of the matrix. And the convention is that you will always put the row listed first, and then the column will need to be listed second, which is just like what we do with the indices. We put the row followed by the column for the index, for the subscripts. So let's go ahead and take a look at example 10.1 again. And if I look at matrix A, we already discussed that it has 2 rows and it also has 2 columns. So we call this a 2 by 2 matrix. And anytime the number of rows and the number of columns are the same, we call this a square matrix. And it will be the square matrices that are of particular importance to us when we start applying matrix structure to solving systems in section 11. So we'll make sure that we pay close attention to that as they come up. Matrix B, this one has 2 rows as well, but it has 3 columns. So this would be considered a 2 by 3 matrix. That's the order or the size of that matrix. And in the last example, C, 1 row, 1 column, not too terribly interesting here, so we'll just call this a 1 by 1 matrix.